Welcome back to our continuing conversation about supply and demand. Today, we're going to be looking at two concepts known as consumer and producer surplus. And we're going to be able to not only describe what consumer and producer surplus are and be able to find them on a graph, but we'll be able to explain why consumers and producers benefit from trade. And we'll be able to sort of measure the amount of benefit that both sides receive when they are at equilibrium. So let's get started. We could look at a very simple market. Let's say the market for used college textbooks. And let's pretend there are five people in the market, five people willing to purchase or interested in purchasing used textbooks. We have Alicia. Alicia's maximum willingness to pay is $59. So don't know what the price of the book is, but anything between 0 and 59, Alicia's in. Brad, maximum willing to pay 45, Claudia 35, Darren 25, Edwina 10. Now, I don't know how many textbooks are going to get sold because I don't know where the supply curve is yet. I do know all the potential quantities and prices, however, and I do have a demand schedule. If the price were, say, $40, then I know that two textbooks will be sold because only Alicia and Brad are willing to pay at least $40. Claudia is not willing to pay 40. Neither is Darren or Edwina. So the price is 40. Those three are out of the market, but Alicia and Brad will be happy to buy a book. And if the price were $20, then I know that there will be three textbooks demanded because only three people are willing to pay at least $30 to get their text. Now, again, I don't know what the price is that they're going to have to pay, but I do know based on price what the quantity demanded will be. So our consumers' willingness to pay for a good is the maximum price they are willing to pay to be able to get that good. The price they pay will almost certainly be different than their maximum willingness to pay. The difference between what they're willing to pay and what they have to pay is known as their consumer surplus. So if the price is $30, then Alicia was willing to pay $59, only had to pay 30. So it's, imagine Alicia walking into the college bookstore. She's got $59 in her pocket. She has to give 30 to give the textbook. She's got $29 left over. This is her consumer surplus. It's the leftover money she was willing to part with and didn't have to because the price was less than her willingness to pay, her maximum willingness to pay. And if the price is $30, then Brad has $15 in surplus. He was willing to give up 45 bucks. He only has to give up 30. 15 still in his pocket. Claudia has a $5 consumer surplus. So if the price is $30, in this example, the total consumer surplus would be the sum of all the individual surpluses. So Alicia's, Brad's, and Claudia's added up together tells me if the price is $30 in this market, there's $49 in total consumer surplus. That means all three get their book and they have $49 left over. And so graphically, we see that if the price were $30, Darren and Edwina are out. They're not willing to pay 30. They're willing to pay a price for the book, but not as high as $30. Only willing, in Darren's case, go up to 25 and Edwina 10. If the price were to drop from 30 to 20, we would see an increase in consumer surplus for two reasons. One, because now Darren is buying a book. He wasn't willing to pay 30, but now he's willing to pay 20, right? He's willing to pay 25. So if the price is 20, Darren has $5 in consumer surplus, but every other person before him is getting an increase in consumer surplus because the price is even lower than before. See, Alicia was at $29 in consumer surplus, but now at a price of 20. Alicia's consumer surplus is now $39. So as the prices drop, as we move down along the demand curve, we tend to see an increase in total consumer surplus. And so if we were to extend this to a larger market, say 1,000,000 items, then we could roughly approximate the total consumer surplus, which is the sum of all the individuals, by measuring the area of the rectangular area bounded by the price and the demand curve. So consumer surplus is the area, this rectangular area, above price but below the demand curve. And we could calculate that amount as 1/2 base times height, because that's the formula we use for an area of a triangle. So consumer surplus is always the difference between my maximum willingness to pay and the price that I actually have to pay. Producer surplus is similar. Again, we could assume that there's a market for used textbooks and that there are 5 people willing to sell their textbooks: Andrew, Betty, Carlos, Donna, and Engelbert. And each one of them has a price they're willing to accept. Andrew's willing to sell his book for as little as $5, whereas Engelbert will hold on to his book unless he can get a price of $45. Again, I don't know what the price is. It depends on where supply and demand intersect, but I do know that I have a supply schedule that would tell me that if the price were $30, for example, that there would be 3 textbooks sold. Andrew was willing to sell for 5. Betty was willing to accept at least 15. Carlos was willing to accept at least 25. That's all better than 30. So they're in. But Donna would need to receive $35 in payment for her to part with her textbook. So if the price is only 30, Donna is not part of the market. She's out, and so is Engelbert. So the supply curve is showing us the minimum price that is needed to incentivize someone to sell. They'd always like a higher price. This is the minimum they need to get. So at a price of 30, Andrew has a certain producer surplus. He was willing to sell for 5, but he gets 30 in exchange. He was expecting to only have $5 in his pocket after getting rid of his textbook. Now he has 30, so he's $25 more than he had anticipated. Betty was willing to give her book up for 15, but now she's walking away without her book and $30, which means she has $15 in producer surplus, and Carlos has the same. He has a $5 consumer surplus. So we can add up each individual's producer surplus and add it together to get the total market surplus. In this case, it's $45. In a table, again, you can see Andrew's willing to accept 5, but he gets 30, so he has a $25 producer surplus. Betty has producer surplus, Carlos does. But Donna needs to get 35 in order to sell her book. She's only getting 30. That's not a good deal for her, so she's not participating, and nor is Engelbert. And we could extend this across many, many, many sellers as well, just like with consumer surplus. The sum of all the individuals is total producer surplus. If we've got 1 million people selling products, that's 1 million vertical lines marking the distance between the supply curve and the price. Well, if we do 1 million lines in this small area, it begins to fill in that whole triangular area, so we can approximate it using the area of a triangle formula, 1/2 base times height. So total producer surplus is generated by comparing the minimum price to the price itself. So it's the area below price, but above the supply curve. Where the two intersect determines the market price and quantity. And that intersection point, that equilibrium point, is where we will see the maximum total surplus when we add consumer and producer surplus together. And it turns out that this point, point E, is not only where we have the maximum surplus available, but it is what we call efficient, because we cannot make one person better off without making someone worse off. If we want to sell 1,001 books, we can't do it without either making the buyer suffer or the producer suffer. But both sides do not benefit. See, before that, between 0 and 1,000, both sides are winning. Both sides are either receiving more money than they needed, producer surplus, or paying less than they were willing to pay, consumer surplus. But in both cases, they win. If the price is $30, then the first person was willing to pay way more to buy the product, in this case, books. So they have surplus, they're winning. And the supplier, the producer, was willing to accept a whole lot less than 30, but they get 30, so they're winning. So both sides have a mutually beneficial trade, both win. And that's going to be the case from 0 books all the way to 1,000. But what happens if we try and sell another 10 books or 100 books? If we look at the market from equilibrium, we say, let's sell more than the equilibrium quantity. Well, what happens? Well, one thing that might happen is that in order to sell 10 more books, we'd have to drop the price to $25 because the demand curve shows us that in order to sell more, I have to drop the price. So I could lower the price to $25 to sell 10 more books. The problem is that if I do that, suppliers, in order to sell 110 books, suppliers need to receive a price of 35. So, but they're only going to get 25. So they don't want to make that trade. Now the government could make them accept that trade, but that would come at the consequence of harming the supplier. So I couldn't make the demanders better off without hurting the suppliers. And similarly, I could sell the book for 35. I could make the suppliers happy and force demanders to pay 35, but they only want to pay 25. So in order to get them to buy 110 textbooks at a price of 35, I have to hurt the consumer. So suppliers win, but consumers lose. So it turns out that anytime you have an equilibrium point, that is the most efficient place. If you try and go beyond, then you are going to hurt somebody. So you can't make one person better off without making someone worse off. Then you have eclipsed efficiency, and you are no longer at equilibrium. We will maximize our surplus where the intersection occurs between the supply curve and the demand curve. Another thing to keep in mind is then that any area to the right of equilibrium is what I call Neverland. You will never find the answer in Neverland. If we were to have a price less than 30, we would be producing fewer goods than people want. We'd have a shortage, and we can only sell what's available. So the quantity in the market will be to the left of the equilibrium point. There is no answer to the right. So any area sort of to the right of equilibrium, Neverland, we'll never find the answer there. So it's largely irrelevant to our conversation unless either the supply or demand curve shifts and puts a new equilibrium point in that area, in which case it becomes relevant to us. So works and problems. And when we come back next time, we're going to talk a little bit more about surplus and what happens when we don't reach equilibrium.